I made it.
Only 45 minutes.
Like an hour and 15 minutes.
Oh, no, so. Not even do it.
I mean, conversation from opposite sides of the room. So,
No, I'm actually talking about
right, in the warm up.
Boy, I have actually. Thank you.
Oh. No, it's. You okay? Yeah. Up to bigger than packet? Yeah. Well, you have the current packet? Yeah, yeah. I think so. Just this last. Oh, yeah. They don't also check all the touch back.
We went over it.
All of them from the touch we can.
We went over it.
That's why you check all the touch back.
Oh, yeah, I forgot to put the quiz. Hold on. Yeah, the quiz is instead of being out of what was that, 50 points? I'll just decrease the number, whatever it was that was not fair. So it'll be like out of 45, and you'll keep whatever points you had.
Also, it's possible we could like.
So you can have more.
Feel like 100.
Yeah, you could actually get 50 out of 45.
Yeah.
I think that'll do it.
Yeah.
I'll mark that up and get it back to you.
That'll suffice.
Okay, thank you. Okay, sketching this, we recognize that this is what kind of function? Yeah, make sure you're focused. I just like, I'm not sure if you're facing, but it looks like you're facing close enough. Okay. How many points do I want to see? 3 points from the parent graph. I want to see 0, 1, 1, 5, and -1, 1/5. Oh, thank you. Sure is. There we go. So that is the parent function. And then this is going to be moved 1 to the right and 2 up. So we just take those 3 points and move them 1 to the right and 2 up. So 1 to the right and 2 up. I'm just approximating here because I don't actually have a grid.
Do we have the right horizontal asymptote?
And anytime you're graphing it, but aside of the 3 points, I do want the horizontal asymptote. And that horizontal asymptote, which was at y equals 0, is now y equals 2. It should fit perfectly there. So again, my scale's a little bit off here, but this is y equals 2. So this is what I'm looking for. Ben, do you have any questions?
Beautiful graph right there.
Oh, wow. Also comment. Thank you. Should I move on?
Yeah.
Let's do it. Yes. So packets.
What actually is 29? Yeah.
And we're going to go right to this. Okay, I'm going to give you a moment to read through this. Try to fill in the blanks to the best of your ability.
Oh, crap. Oops. Oh, crap.
So these four, you're filling them out to the best of your ability. Welcome to discuss with your neighbors.
Yeah, we are crazy. Yes, I have an office, so I think I can do that.
So this is a review from a fairly long time ago. So it may have left your brain. Number one, only blank functions have inverses that are functions. Good guess.
Okay.
That's a good guess. It starts with a number, not a letter. 1, 2, 1. Only one-to-one functions have inverses that are functions. A function f has an inverse function, and that is read, remember, f inverse. If it passes the horizontal line test, otherwise known as
Flat.
H L T, or you can think about it as a moving x-axis coming up and down through the kind of scanning to see if it's going to cross through more than one point. So if it passes a horizontal line test, the function is 1, 2, 1. The function has an inverse. The first step to find this function is to switch. Oh my goodness, x and y. Yeah. If two functions are inverse, then the domain of f is the range of f inverse, and the range of f is the domain. And that's just switching the x's and y's. And lastly, the graph of f inverse is the reflection of the graph of f. Would you show me the line that it's reflected about? Do you remember? It's not the x-axis,
Symmetry.
not the y-axis. There's symmetry in the line. Y equals x. That has a diagonal line. Y equals x. Okay. Does the function f of x equal to the x have an inverse? I think does it? How do we know? Are you sure it's 1 to 1? How do you know? Does he know? Because you're a guy who knows things.
He doesn't know that I know that you know.
Oh, you triple backed on it.
Yeah.
So if I were to graph the function, how do we know that it has an inverse? Because the function is starts with a number. It's 1 to 1, isn't it? How do we know it's 1 to 1? Passes the horizontal line test. We just did that. So this is very specific to this function. So yes, it has an inverse. Find the inverse and graph both the function and its inverse. Would you go ahead and graph the inverse? And then we'll find it out.
Well, if it's 0.01, you know what's gonna happen to it, don't you?
Right, but you switch to X and the Y. That's the inverse functions. It's right there. Your neighbors are okay with these? So the other point, 1, 2 becomes 2, 1. What other point should we use? Yeah, it was 2, 4. Now it's 4, 2. We also have 3, 8, so we could do 8, 3. But those are easy points from the exponential, aren't they? Super easy. I need another point though, maybe one that's not quite as easy.
Negative.
Yeah, the negative. At this point here, which was -1 comma 1/2 is now. So you see where that is? And it's falling into line nicely, isn't it? So we're still gonna look like this here. And then maybe like this. Does this seem about right? No, I kind of messed up.
Closer.
It's closer, yeah, yeah. The first one has a horizontal asymptote, so I hope it makes sense that the second one's going to have a vertical asymptote. Right, so yeah, it's gonna look something like this. Okay, so we haven't seen that function before, but it's definitely a function. Let's find what it is. It's like a mystery. We have y equals 2 to the x. The first step when finding the inverse is 2. Switch the x's and y. So x equals 2 to the y. Next step, solve for the new y. How do you do that here? What's that? What's that? You could try to set it equal to 0. What's that? Yeah, that's an interesting idea. Take the y-th root of both sides. But then we're solving for 2, and then we have the y-th root of x, and we haven't solved for y. We've solved for 2. Can we divide both sides by 2?
Ooh. I'll get the root of 2.
We could divide by 2, but that doesn't solve for y. The problem is that we don't have an operation that will solve for the y. So that's what today is. Yeah, so today is introducing a new operation called logarithm.
I'm excited that.
You got it now. That was quick. I didn't even say anything. If a to the b equals c. Only if you're not paying attention. You got this. You got this. Did someone tell you this unit becomes hard?
Wait, I'm pretty sure you said it was easy last class. It was last.
Yeah. So it's more likely to be hard if you don't pay attention, is what I'm saying. So I'm just gonna tell you straight away. This is gonna be log base e of c equals b. This is by definition. This is a subscript. Yep. Oh, that's an a. Log base a. That looked like an e. I said e. It's gonna be nay, and I'm just confused with the e's and the a's today. Or I just made a mistake. Yeah, log base A of C equals B. Yeah, so this is red. Log base A of C equals B. I want you to notice if you're typing, log C and B would all be in a single line. The only thing that'd be different is that base, whatever the base is. And this is just the definition of logarithm. And I think it suffers from just like a boring name, like logarithm. It sounds so serious. It's just an exponential equation mixed up. So let me talk about how to do these. We're going to rewrite each equation in its equivalent form. A, do you see what the base is for this statement? It's 5. So I'm going to start with 5 in my exponential. The bases are the same. So it's going to be 5 to the other thing. It's not going to, you're not going to see this. It's not 5 to the x. It's 5 to the second power equals x. And I've finished the problem.
Where's log?
It's just, by definition, these are equivalent. So I'm just rewriting it.
Right, so like this is the same as this, this is the same as this.
You don't want to simplify that to 25.
There's no need. It's not saying to solve for x. It's saying to write in its equivalent form.
But I want to see the exponential. Every log statement has an equivalent exponential. Every exponential has an equivalent log. Like, we're not going to make x equal 142. I'm going to rewrite it as a logarithm.
Logarithm is the full name. In Spanish, logaritmo. Yeah, thank you.
No, I'm definitely gonna Italian now. Sounds like Italian brain.
Okay, so could you already do B?
Yep.
I think you could. I'll call someone for B and C. Just make sure that you're in the neighborhood. I've gotten it right. Okay, so B, just Siri.
I got like probably like web log way as
Mhm.
I put B in the base. And then you figure that part of the
Do we agree? Perfect. It's purely mechanical. Right? It's just putting places where things where they belong, based on the definition of what a logarithm is. Siri, thank you. Nicely done. C. Luke. You sure about that? Is he correct?
Yep.
Yeah, perfect. Once you know that the bases are the same, everything else kind of lines up. And make sure you don't have like 3 to the 7. You're not going to see those numbers together. Well, remember how I read this? It's log base 3 of 7. And when you're talking about exponential, 3 is the base of the exponent. No, by definition, they're always the same. So D, E, and F give you exponential. Please rewrite in logarithmic. I'm sure you could do that already. I'll call on 3 people in just a moment. Okay, so for sorry, for D. And there's, what'd you get for D? Two equals log what? Log base 12 of X? Yeah, if you say log base 12X, I'm gonna put an X down there. So log base 12 of X is second. Are we good with that? Exactly what I'm looking for. Thank you, nurse. Joseph, help me with E, please.
Yeah, but I think that.
You're gonna want to start with log, probably.
Oh, yeah.
But
Uh,
is it base 8?
wait, I didn't base.
You're good.
Okay.
Log base B.
Okay.
B8 equals 3, like that. Log base B of 8 equals 3. I'm sure you have this written down. It's just hard to put it into words. So that's a whole other thing. Joseph, thank you. Are we good? Raquel, can you help me with that, please? Is this correct? Did she say it correctly?
Yeah.
Perfect. Thank you.
Perfect.
I don't usually start with the exponents. I like how you and Anaris both did that. That's great. I like to start with the log because for me we're doing the bases are the same. So log base, whatever it is, of whatever equals whatever, putting all the pieces in the right place. But they are equivalent. It doesn't matter at all. So yeah, you two are perfect. You got it right. Just different ways of thinking about it. Okay, we're gonna evaluate some of these. Log base 2 of 16 is it's a very likely kind of question you're gonna see on our next quiz, definitely on the test. Don't remember offhand. It's definitely not next, guys. Okay, so for this one, we're gonna say, oh, I don't know what this equals, so I'm gonna call this equal to X, right? I don't know what it is. And now that it's a full statement, I can rewrite it as exponential. Give a moment to do that. And again, check in with your neighbor, make sure that it's making sense. Yeah. Can you please show me what we got for A, please? Did you get anything? Did you get an answer? Well, it's asking you to evaluate, which means we need to come up with the value of that quantity. So now that it's in this form, 2 to the x equals 16. It's in a situation where you can figure it out. 2 to the what equals 16? 4. So this is equal to 4. But that's the final answer. So we could automatically say that this is equal to 4, but yeah, what's that? I thought to myself, 2 to the what equals 16? Or I could rewrite the 16 as 2 to the 4th, and now that they have the same basis, we could just set the exponents equal to one another. Yeah, that's it. So for B, I don't know what that's equal to, so I'll set it equal to. We write it as 7 to the x equals 1 over 49. This is a little bit of a challenge. We're on the right track. -2? Is this true? Because I know that 49 is 7 squared. So does it make sense that this is the same thing as 7 to the -2nd power?
Yep.
So yeah, x equals -2. That's what we're looking for. X equals -2. I'm going to change some of these. No. Good question. Well, these 10 of 10. Let's do these two.
How do you do it with your job?
I'll talk about after these two. So C and D, try them.
45 for the X.
Show me what you got for C. No, I'm seeing threes all around. We set that equal to X, so 3 to the what equals 27. Yes, 3 cubed equals 27. In your knowledge. And D, show me what you got if you got it already. Yeah, those one, yeah, nice. It's equal to X. So 10 to the X equals 10. There's only one number this could be 1. And that first one I crossed out. Another challenge. We have 25 to the X equals 5. Is it 1/2? How do you know this? Yeah, we're taking a square root here. Perfect. Square root. Square root. Yeah. I'll give you a moment to try A, B, and C. Okay, for A, show me what you got. It's 1. Did anyone get B? You show me what you got for B? Nice. Yeah, I'm seeing zeros. Let's make sure this makes sense. Because if you don't know, set that equal to X. A to the X equals 1. So remember, anything to the 0 power is equal to 1. Okay, that just comes from our knowledge of the fundamentals. Show me what you got for C. It is 5. And this leads us to the basic properties of logarithms. So log base B of B is always going to be equal to 1, just like it was in A, and just like it was in one of the ones that I gave you up here, like in D. Oh, so this is 1. Log base B of 1 is always going to be equal to 0. And log base B of B to the X is always going to be equal to X. Okay, so let's any questions so far? Okay, go ahead and graph this function and its inverse. Yeah. We don't know what it's equal to, right? So it's just X. So 4 to the x equals 4 to the fifth. Just by putting that into our exponential form. So 4 to the x equals 4 to the fifth. We have 4s on either side, matching. By observation, x is equal to 5. They kind of like canceling. We would say by observation. Matching.
The first box is the inverse, but at the same time, it's crossed by that.
Yeah, that's okay.
So the inverse is very kind very often, so it's crossed.
Well, they're two different functions, aren't they?
Yeah.
That's fine. It shouldn't be crossed by its own function, though.
Hey, do you own like 1.4?
Yeah, just example 4, A, B, and C. And D, thank you. If we have these points, it's inverse. Is it difficult to graph the inverse? And just take the points that we have and flip them. 0, 1, there's 1, 0, 1, 3, 3, 1, 2, 9, 9, 2, negative 1, 1/3, 1/3, negative 1. We have equations of the asymptotes and show them with dotted lines. Okay. Y equals 0. X equals 0. Want to be clear, y equals say f of x. And this one is y equals f inverse of x. Are we good up to here? Find the equation for f inverse of x. Okay, well, I can start with y equals 3 to the x equals 3 to the y, and whereas before we were stuck, we now have a tool to get out of this. The tool is called logarithms. Can you please rewrite that as a logarithmic statement? Check with your neighbor. Hey, Upton, how did you rewrite that equation?
How many distance?
Okay. What should I start with?
Um,
Let's start with log.
yeah.
Okay. Every log has a base. You know what the base is going to be for this one? Good. Log base 3 of, good, equals, thank you. And suddenly, y has been solved for. And that was our goal, to solve for that new y, log base 3 of x, which I'm going to rename, instead of y, I'll call it f inverse of x equals log base 3 of x. Upton, thank you for your help. So that function, that green function, is a logarithmic function. Just the inverse of an exponential. Go ahead and complete D. Get the domains and ranges. Okay, I want to hear. Domain and range of f of x, Gideon. Do we agree negative infinity to infinity? Thank you. And we're able to get the range? Do we include that 0? Parentheses. So we don't actually include it. We put the parentheses there. Missed it and still on top of things. Thank you. Yeah, 3 to the nothing will ever get us 0. It's close to 0, but not 0. And Matea, help me out with the domain and range of the inverse. Are we good?
Yep.
So they match the graphs, don't they? And also remember that the domain of the function is the same as the range of its inverse. So if you look, right, these match. These match. That's always going to happen if you do it right. Thank you, Matea. Okay, I give you a moment to do 5 and 6. Not graphing anything, you're just finding inverses. Can we start calling? Tess, can you help me with example 5, please? Where'd that come from? Okay. Are we good? And that y is just the same thing as not f inverse, but in this case, g inverse. That's it. Thank you. So we see that the inverse of 5 to the x is log base 5 of x. We see that the inverse of 3 to the x was log base 3 of x. I think we see a pattern there. Example 6. Did I do this one? Did you get it? Jack, can you help me with example 6, please?
Yeah, I go y or I guess f of the inverse x. Equals 4.
4x, like this?
Yeah,
4 times x?
or 4, sorry, 4 to the
4 to the x. How'd you get that?
well, because base is 4 and then multiply by x, so x times x and the data.
Okay. And did you do that in your head? You just kind of thought about it like this and then
Yeah.
just did it? Okay. Now it's not being multiplied. It's log base 4 of x, but it's not multiplication.
Yeah.
We know what you mean. Yeah, and once you know stuff, like once you're a person who knows things, you can go directly from here to here. Those are just inverses of one another. Okay, I'm going to give you a few minutes to ask one another questions, zone out. 44 right now, we'll resume at 48.
Hey, can you draw a bombardino, carpintero? Bombolini.
Oh, yeah.
Hey, that is that. Boom, boom, I'm not gonna get a tax right now. Oh, the brackets. Three black and blackness. Go. No, blackness, the blackness, Hey, Ben, war number 2. Let's go. War 2. Hey, let's bury them, Bard. Hey, the video's just dropped.
No, but you can't.
Still follow the ball.
Hey, Jack.
I brought my
The
work.
brackets
So
over.
it was been 25.
What is that? Come on, bro.
Bro, that's there goes, you folded that.
Ben,
Bard. That is crazy, Bard. Oh, look at this. Look at this perfect place. Incredible. James. Wow. Wow. Yeah, we look like you're right.
Okay, wait. You're gonna see. Over under.
Okay. Let me finish up the
Ooh,
question. And then
ooh.
after, that'll be time.
What's your name?
And look at this. Ben, come here. It's like you get to see this. Look at it.
Maybe
It's back in this video. Man. This is so cool. Look at this video, man.
Okay, wait. Over under.
It's so yeah. That's
Over on
brains.
Wait, how do you go?
Because I get them from the like window. Yeah. Hello.
Okay, wait. Yeah. Oh, I.
No, why does he look like a frog?
Yo, put that, quick.
Red. Yo, why does he look like that?
I don't know.
Oh crap.
Okay.
Yes, I'm seeing.
Oh. Hey, thanks.
That's insane.
Yeah, crazy work.
He is.
Yeah, he's quite good.
Nico Armstrong? No.
Yeah.
Okay, folks, let's continue.
Wait, did you change the score?
I didn't change the scores, I changed what it's out of.
But that would change the,
So that will change like a percentage.
wait, so what's it out of now?
About 45, I haven't counted it yet, though.
But you'll put it in the grade book.
Yeah.
Okay.
There's like this one.
Like,
That's okay.
Okay, wait.
I'll definitely get to you.
hey, what I mean?
Okay, folks, one last one. One last problem. Let's do example to I can come back to the homework. It's okay, they go quick. A lot of them go quickly. But can you make sure you're working on example 7? James, did you finish example 7 yet? So I'll figure out exactly, but about 45. To be at 42. Okay. Are we good? Okay, of course. Here we know what 3 to the x looks like, but the +2 will take that graph and move it 2 to the left. Okay, so when we find the inverse of that, Ethan, how'd you do it? What'd you get? Okay, what of what? Three of x plus 2, like this, is equal to y. Okay. Well, the inverse, so the first thing you do is 3 to the y plus 2 equals x. Yeah. We switch the variables, so 3 log base 3 of x. Okay, good. And what are we gonna do with that +2? Nice. Yeah, so it becomes log base 3 of x minus 2 is equal to y. And we'll rewrite that y as g, how do you say that? G. Thank you. G inverse of x. Thank you. Now notice it went from a shift of 2 to the right, 2 to the left. We were dealing with the parent function, but this -2 is a shift. Which direction? Tell me which direction this is. Oh, yeah, show me left and right. It's interesting. That 2 is outside the function, isn't it? So it's 2 down from that basic log function. Ethan, thank you for your help with that one. Okay, folks, you have some time to work on your assignment. That was a tough day, a lot of new stuff. You did great.